It's important to also remember that you shouldn't always get into the habit of doing a base, matching the base and canceling it, because sometimes that actually makes your life a little more difficult. For instance, this one you'll have 3 to 2x minus 7 equals 9. You can solve that, and we can use some rules we did before to solve that, but the easiest way is to just recognize that you know what log base 3 of 9. There's no variables in this. I know what that evaluates to, because 3 to the second power gives me 9. So this whole thing just equals 2. So from there, I can just add 7 to both sides, divide by 2. So you get 9 halves. Now the other thing that's important to note is the only time you're going to have extraneous solutions is if the variable's in the base or the argument. The variable's all over here outside of the log. Therefore, there's no way I could have a extraneous solution, so I don't have to actually check this one. But you can always check it, just double check that it's actually correct. So same thing with this one, log base 5 of 125. Don't just do a base of 5 on both sides if you can evaluate. I mean, you can still solve it that way, but this is just a little easier. So log base 5 of 125 is 3. I can subtract 5 from both sides, so I get negative 2 equals 4x. Divide by 4, and I get negative 1/2 is equal, oops, don't know what I did there, equals x. And that's that. Let's do one more. So same idea with this one. This is another prime example. You can certainly go ahead and do a base of e to both sides, because natural log is base e, and you'll get e to the negative x plus 1 equals e to the 5. And then you can recognize, oh, well, I can just get rid of that. Or, because they're the same base, that's why you can get rid of them. Or, if you recognize that natural log and base e are inverses of each other, you'll actually notice right here they already cancel each other out. And so you can say negative 1x plus 1 is equal to 5, and just go ahead and solve that. And then divide by negative 1. Oops, that should be a positive 4, sorry. The answer is negative 4. And you can plug negative 4 in. That gives you a positive 4 plus 1, so 5. So e to the 5th is greater. So this one works.